So we basically got our concept down. We have a control transistor, and then each one of the pass transistors shares the current load, current distribution for the regulator. Yeah, I was favoring putting the collector back here and having the collector tied in, but I think I'm going to switch that plan and go for the emitter back here and the collector out front. So that means the emitter will be back here and the collector will be out here somewhere. And they'll be big, like 3/4 inch wide power planes. I'm doing that because the degeneration resistor is right here, and I'm favoring this copper strip instead of going this way to what would have been the emitter. I'm favoring going backward. So I just have this big thick power plane there. Either way, it works. And in both cases, I still need to do these little jumpers to the to this side. So, you don't really gain too much. This one, of course, was nice because we have these big 5-watt resistors here. They do all the jumpering for us. So as you can see, they jumper over the control planes. So it's not really an issue with the bigger resistors, but since we've got small flat packs, I have to do this a little differently. But I don't think that's a big deal. I'm just hoping that I don't need another feedback resistor. This one is part of a different design, and it has these 100 ohm feedback resistors for the current control. I'm really hoping I don't need to do that. And all of these boards are going to have these terminals. They're really cool. I like them a lot. I only needed basically one of these, and this survived. This survived a 60 amp spike. The rectifier didn't survive. It blew up. But I was only using one of the terminal connections for the power. You see it's really over soldered. That almost looks like a weld. But this easily survived 60 amp short circuit. Blew the rectifier completely out. But there's no harm done to it at all. It just took it. So 3/4 inch wide trace should handle 40 amps. You see this actually has a cutout to it, so it's only about 3/4 of an inch here. This is a little bit more than 3/4 here. Of course, the current is cut in half, so that'd be 30 and 30. But the reasoning is I think it's okay. There might be some heating in these conductors. There should be some heating, but we'll plate the board too in the silver solution, and that'll add maybe another half a thou of thickness. So hopefully that'll help with some of the losses. And if we have to, we'll strap it. I'd rather not do that, but if I have to, I can prepare some strips to strap it, or you can always use the solder wick. That's a cute thing I've seen people do, is they'll lay down a solder wick and they'll just solder it right into the board. Clever. It doesn't look great, but it definitely works. So we'll go from here, and the next is placement, then drilling, then etching, and then cussing because we did it wrong, and doing the whole damn thing over again because we can't do anything right right way one time. It has to be done 4 or 5 or 12 or 20 times. Oh my God. Ugh. Okay, well, that's over 5 minutes, so see you soon.